We are going to start now the next lecture, lecture 2 of chapter 10, class 10 mathematics, circles. Now the question we have is, from a point P 10 centimeter away from the center of a circle. So we are talking about a point P is there and it is given that it is 10 centimeter away from the center of the circle. A tangent is drawn. This PT is the tangent that is drawn over here, and the length of the tangent is given 8 centimeter. We have to find the radius of the circle. So the result we are going to use now, it is the previous we have studied that if PT is the tangent and OD is the radius, then this angle at T, this will be of measure 90 degree. Means this triangle PTO, this is right angled triangle. So what we will have is that PT square plus TO square, that is equal to PO square. We want to find the value of TO square. So that will be square root of 10 square minus 8 square. That is equal to root 36. That is equal to, this is not square we are talking about. This is TO value. This is 6 centimeters. And this is the radius of the circle. Similarly, this next question is a tangent PQ. Now the point that is given over here, it is Q. This is the point P. It's drawn to the circle whose radius is 5 centimeter. Radius of the circle is 5 centimeter and meets a line through the center at the point Q. We are saying PQ is the radius. It is meeting this line from the center at the point Q, and the length of this OQ, this is given to be 13 centimeter. Again, we have this OPQ is right angled triangle. We have to find the length PQ, and this length PQ will be square root of 13 square minus 5 square. This comes out to be square root of 144, and the answer comes out to be 12 centimeters. Now in the next question, it is given that AB is the diameter of the circle. This AB is given to be the diameter of the circle with center at O, and AT is the tangent. This AT line, this is given to be the tangent, and it is given that if angle AOQ, this angle we are talking about, this is given to be 58 degree, we have to find the value of the angle ATQ. We are talking about, we have to calculate this angle. Now in this given figure, this angle AOQ, this is on the arc AQ, and this angle ABQ is also on the arc AQ. So the measure of this angle ABQ will be half of the angle at the center, and that comes out to be 29 degrees. Now this AT is the tangent and OA is the radius. So this angle over here, it is 90 degree. Now if we look at the triangle BAT, we are talking about this triangle BAT. We are saying this angle will be 90 minus 29 degree, because this angle is 90 degree, this angle at B is 29. We are calculating the angle at T, so it is 90 minus 29 degree, and that comes out to be 61 degrees. So the value of the required angle is 61 degrees. Next is tangents PA and PB are drawn from an external point P to two concentric circles. So these are the two tangents we are talking about. This is the tangent PA and this is the tangent PB. One is the tangent to this larger circle at A, and second is the tangent to this smaller circle at B. And it is given that the radii are 8 centimeter and 5 centimeter. So this length OB, this is given to be 5 centimeter. This length OA is given to be 8 centimeter. It is if AP, we are talking about this length, it is given to be 15 centimeter. We have to find the value of BP. We have to find this length. So if we look at the triangle OAP, we are saying the angle at A, it is 90 degree. One important thing to note over here is that if we draw the tangent to some other point on the larger circle, then the length of this tangent will be 15 centimeter. This thing we already know from our theorem that we have already studied, that if we draw the tangent from one point, two tangents we are drawing, then length of both these tangents they are equal. But these are tangents to two different circles, so we are not using this result. So in this triangle we are saying this side is 15 centimeter, this angle is 90 degree, and this side is 8 centimeter. So we can calculate the value of OP, and it comes out to be square root of 8 square plus 15 square, that is equal to square root of 289, that is equal to 17 centimeters. Now this length OB, this is given to be 5 centimeter. So we get that this length PB, this comes out to be square root of 15 square minus this is square root of 17 square minus 5 square, because this angle over here, this is again 90 degree. This is the radius for the smaller circle, this is radius for the larger circle, this is the tangent and radius, they are at the angle of 90 degree. So this is the hypotenuse we are saying. So length of this side is square root of 17 square minus 5 square, that is equal to 264 square root, that is equal to, if we calculate the square root of 264, we get this is, we are talking about square root of 264, so this comes out to be root 2 square root of 66, and when we have to calculate the square root of 66, we are saying the value we will get, it is 8 is the 64, we are left with 2, then decimal is there, it is 16 over here, and because of decimal there are 2 zeros, so we get it is 1 it is 161 over here. So we are left with this 3900. So now the answer we have, it is the number that we are saying, it is 3900, and the next number we will have over here, it is 162, and we are saying we have to multiply it with 2, so we get it is 1622, and the answer we will get, it is 3244. So approximate root of square root of 66 is approximately 8.12. So the final answer we will get, it is 2 into 8.12, that is equal to 16.24 centimeter, or more, if you will calculate up to next decimal place, you will get it is 16.25 centimeters. Now in this next question, we are given that two circles touch each other at the point C. So two circles are given, and it is given that these two circles, they are touching each other at the point C. Touching means that this point we are saying, this is the point C, and if we draw a line passing through this point, that will be tangent to both these circles. Then we are talking about another tangent. Suppose this is the point P on this circle and this is the point Q on this circle. We are talking about this tangent over here. We are talking about this tangent over here, which is tangent at P to this circle, at point Q to this circle, and this point where these two tangents they intersect, that is the point R, and we have to prove that the R is the midpoint of the PQ. So we start with, suppose this first circle we are talking about. For this circle and this point R, we are having two tangents from this point R. One is this tangent RC and one is this tangent RP, and we know that the length of PR and RC, they are equal. This result we know that if we draw a tangent from a point outside the circle, then length of both the tangents, they are same. If this length is x, then this length is x. Now again consider this point R, and there are two tangents RQ and RC corresponding to this second circle we are talking about. Now again we have the same result, that this length of RQ is x and this length of RC is x, because these two lengths, these will be equal. So we are saying both these lengths are equal. So we get that PR is equal to RQ, that is R is midpoint of PQ, and this is what we have to prove. Next is two concentric circles of radius A and B. So two concentric circles means we have two circles whose center is same. We are talking about two circles whose center is same. Suppose the center of both these circles, it is this point we are talking about, it is the point O over here. It is given that the radius of the larger circle, it is A. We are saying this is the radius of the larger circle, this is the radius of the smaller circle. Find the length of the chord of the larger circle which touches the smaller circle. So we want to find the length of the chord of the larger circle which touches the smaller circle. Suppose it touches at this point over here. So what we have is, we have to find the length of this chord. Now when we consider this smaller circle over here, we are talking about this smaller circle, and suppose this point we are saying it is the point A, this is the point C. Then this angle over here, this is 90-degree angle. So this length AC will be square root of A square minus B square. So this value is A square minus B square. Now if we look at this larger circle over here, for this larger circle, this AB is the chord, OC is the perpendicular on this chord, and we know that this C will be the midpoint of AB. This property we already know. So it means this length AC and this length CB, both these are equal to this value. So the total length of this AB will be 2 times the square root of A square minus B square. Now the next question we have is two concentric circles of radius 7 cm and R cm respectively, where R is greater than 7. This is shown over here, that the radius of larger circle is R cm and smaller circle is 7 cm. A chord of the larger circle of length 46 cm, the length of this chord is given to be 46 centimeters, touches the smaller circle. It is touching the smaller circle at point C. We have to find the value of the radius R. Now again, if we look at this larger circle over here, we are talking about this larger circle over here, then for this circle, this AB is the chord and C is the midpoint, because this is the perpendicular over here, this is the, we are talking about the point O, and this point O we are saying this is for the smaller circle. For this smaller circle, this touches this point C. So this angle over here, it is 90-degree. Second thing we have is that this AC and CB, these will be equal because OC is perpendicular from center on the chord AB. So C is the midpoint. So what we get is that this length AC will be 23 centimeter. Now in this triangle, we are talking about this triangle OAC. We have this length OC is 7, this length AC is 23. So we get that the length of AO, it is square root of 23 square plus 7 square, and the answer we will get, this is equal to square root of 578, and that is equal to 17 square root 2 centimeters. So we get that the radius of the larger circle is square root 17 square root 2 centimeters. Next is, in the given figure, the radii of two concentric circles are 13 centimeter and 8 centimeter. So in this given figure, we are saying this length OB we have, this is 13 centimeter. This length OD, it is 8 centimeters. It is given that AB is the diameter of the bigger circle and BD is tangent to the smaller circle touching at the point D. So for this smaller circle we are saying this line BE we are talking about, this is the tangent to this circle. If this is the tangent, it means for this OD radius we are saying this angle will be 90 degree and both these lengths will be BD is equal to DE, both these lengths will be equal to each other. We have to find the length AD. We have to find this length AD. Now if this length OB is 13 centimeter, then we have this length OA is also 13 centimeter. It is the radius of the larger circle. Now in this triangle, we are talking about the triangle OBD. In this triangle, we have this length BD that is equal to square root of 13 square minus 8 square, that is equal to square root of 105 centimeter. This length we have, it is square root of 105 centimeter. We already know that this BD and DE lengths, these are equal. It means this total length BE, this total length BE is 2 times square root of 105 centimeter. Now we are talking about this point E over here, and we have joined these points A and E. If we look at this triangle over here, I am talking about the triangle ABE. What is the property of this triangle? That this side AB we are talking about, this is the diameter of this circle. It means this angle BAE will be right angle because it is the angle in the semicircle. We have the length of this BE is 2 root 105 centimeter. We have the length of this BA is 26 centimeter. So the length of this AE side, this will be 26 square minus 2 root 105 square and square root. And on solving this, we will get the value. This is square root of 256 centimeter, that is equal to 16 centimeter. So we get that the length of this AE is 16 centimeter. Now we have to calculate the length AD. So what values we have? The value of this DE is square root of 105. The value of this AE is 16 centimeter. This angle over here, this is 90 degree angle. So consider the triangle DEA. We are talking about this triangle DEA. In this triangle, we will have the length of this side will be square root of base is square root of 105 square plus the height of this side, it is 16 centimeter. It is plus 16 square. On solving this, the answer you will get, it is 19 centimeter, and this is the required value that we have to calculate of the length AD. So we are saying the length AD, that is equal to 19 centimeters. Next is from a point P outside a circle with center O, tangents PA and PB are drawn to the circle. So this is the point P that is given to us. It is outside this circle. Two tangents PA and PB are drawn to the circle. Prove that OP, this length we are talking about, we have joined the center to the point P, is the right bisector of the segment AB. This segment we are talking about, this is the segment AB we are talking about. We have to prove that this is the right bisector of AB. It means we have to prove that this angle over here, it is 90 degree and these two lengths, these are equal. So to prove this, we are considering first the triangle MAP. We are talking about this triangle MAP, and second triangle we are talking about, it is MBE. For these two triangles, we have these two angles over here. These two angles, these are equal to each other because this PA and AB, these are the tangents, and we know that the line joining the midpoint O to this point P, that is the angle bisector of these two lines. Second thing we have is these two lengths, that is AP and PB length, these are equal because the length of the tangent from an external point, the two tangents that we draw, the length of both these tangents, they are equal. And third thing we have is that this side MP, this is common in both these triangles. So by SAS congruence criteria, we are saying that the triangle AMP, this is congruent to the triangle BMP. Both these triangles, these are congruent to each other. So what we get is that these angles over here, that is angle AMP, that is equal to angle BMP. If both these angles, these are equal to each other, and sum of these two angles, it is 180 degree. It means that both these angles, these are their measure is 90. The measure of both these angles, it is 90 degrees. And second thing we will get is that this length AM and this length BM, these two lengths, these are equal to each other. Both these results we are getting by CPCT. Hence, by combining both these results, we are saying that OP is the right bisector of AB. Now the next question we have is, prove that the tangents at the extremities of any chord of a circle. So suppose this circle is given to us and a chord is given. This AB is the chord. A and B, these are the extremities of this chord, and the tangents are drawn at these two extremities. Now we have to prove that this angle at A, that is MAP, and this angle at B, that is MBP, both these angles, these are equal to each other. So to prove this, we are saying P is the external point over here where both these tangents, they intersect each other. Now the length PA, what we have is this length PA and PB, both these lengths, these are equal. These two angles, these are also equal, and this third side we are talking about, this PM, this is the common side. What we are saying is, we are considering the triangle AMP and we are considering the triangle BMP. We are talking about these two triangles. In these two triangles, we are saying that the angles are equal, these two sides are equal, and this is the common side over here. So what we get is that the triangle AMP, this is congruent to the triangle BMP. If these two triangles, these are congruent to each other, then we get that this angle at B and angle at A, these angles are also equal to each other by CPCT. The next question we have is, in the given figure, AB is a chord of length 9.6 centimeter. This is the chord AB we are talking about, of a circle with center at O and radius 6 centimeter. The tangents at A and B intersect at P. We have to find the length of PA. So to find the length of PA, we are going to do the construction, and we have joined this point P and O. We have joined these 2 points. We have joined P with O, and we have joined this point A and O. Now the radius of the circle is given to be 6 centimeter. So we are saying this length AO is 6 centimeter, and this PO line, it will be the perpendicular bisector of AB. This we already know. So we are saying that the length AM is 4.8 and length MB is 4.8 centimeter. Now we have to find the length of PA. So suppose we are saying that the length PA, that is equal to X, and the length PM, we are talking about this portion over here, this is equal to Y centimeters. Now in the triangle, we are considering this triangle AMO. We are saying the length of this side MO, this will be square root of 6 square minus 4.8 square, and the answer we will get, this is equal to, it is square root of 36 minus square of 4.8, it is square of 4.8, it is 23.08, and on solving this you will get the answer is square root of 12.96 and the value is 3.6 centimeters. So we are saying this length OM, this is 3.6 centimeters. Now next we have to calculate the value of X and Y. So to calculate this, we are talking about the two right triangles. One is the right triangle we are talking about, it is APM, and second right triangle we are talking about, it is APO. This is the right triangle at M and this is right triangle at A. So from both these triangles we can write, from the first this triangle we are talking about APM, we have 4.8 square plus y square is equal to x square. And from this larger triangle APO we are talking about, this is right angled at A, so we have y plus 3.6 square, that is equal to x square plus 6 square. Now if we substitute this value of x square from this equation in this equation, we will get it is y square plus 3.6 square plus 2 into 3.6 into y, that is equal to y square plus 4.8 square plus 6 square. These y square gets cancelled and we are left with this 7.2y, that is equal to 4.8 square plus 36 minus 3.6 square, and on solving this you will get the final answer as 46.08. So the value of y you will get it is 6.4 centimeters. Now we have to calculate the value of x, so we substitute the value of y say in first equation and we will get 4.8 square plus value of y is 6.4, so it is 6.4 square, that is equal to x square. So the value of x square we will have it is 40.96 plus 23.04, and the answer we get it is 64. So the value of x we have it is 8, because negative value we are not considering. Basically the value of x we have it is plus minus 8, but x over here it is the length, so we are saying we are neglecting the value x is equal to minus 8, and the answer we will get x is equal to 8 centimeters, and this is the required value. Next we have is two tangents PA and PB are drawn to a circle with center O from an external point P. This is the external point given to us. We have to prove that angle APB, that is equal to 2 times angle OAB. Now we know that the length of this PA and PB, both these lengths will be equal. So it means this angle at A, suppose it is y, then this angle at B, this value is also y degrees. Second thing we have is that this angle at A, this measure of this angle is 90 degrees. So from the triangle APB, from this triangle we are talking about, we have x plus y, that is equal to x plus 2y, and the value is equal to 180 degrees. And the second thing we have is y plus angle OAB, this is equal to 90 degrees. So if we multiply this second equation by 2, we get it is 2y plus 2 times angle OAB equal to 180 degree. The first equation we have is 2y plus x is equal to 180 degree. If we subtract both these equations, we get these values, these are subtracted, 180 and 2y, this gets cancelled. We are left with this 2 times angle OAB minus x is equal to 0. So we get x is equal to 2 times angle OAB, and this value of x we are saying this is equal to angle APB, and this is what we have to prove. Next is in the given figure, the incircle of triangle ABC touches the side BC, CA and AB at the point P, Q and R respectively. We have to prove this relation. So we are saying that all these points, if we consider, say I am talking about this point A, then this AR and AQ, these are the tangents over here. It means the length of this AR and AQ, these are equal. Similarly, the length of QC and PC, it is equal. And similarly the length of BR and BP, these lengths are also equal to each other, because if we consider the point C, we are saying the CQ and CP, both of these are the tangents, and the length of the tangent from these 2 points, these are equal. So we have written these 3 equations over here, that AR is equal to AQ, second BP is equal to BR, and third is CQ is equal to CP. When we add these 3 equations, we get AR plus BP plus CQ is equal to AQ plus BR plus CP, and we are saying suppose this value is equal to K. We are saying this value is equal to some constant K. Now if we have to calculate the perimeter of this triangle, it is AB plus BC plus CA. The value AB we can write it is AR plus RB. The value BC we are writing it is BP plus PC, and value CA we are writing it is CQ plus QA. So we are saying from this equation over here, this first equation, we are saying the value of AR plus BP plus CQ, this is equal to K. I think the value of this equal to K. Similarly RB plus PC plus AQ, this value is also equal to K. So this total value comes out to be 2K, and this is equal to the perimeter. So we get that K is equal to half the perimeter of triangle ABC. Now combining these results, we will obtain this final result that is to be proved. Next is, in the given figure, a circle is inscribed in a triangle PQR, and the length of the sides, we are talking about this side PQ, it is 10 centimeter, QR is given to be 8 centimeter, and this PR is given to be 12 centimeter. We have to find the lengths of these sides we are talking about. It is QM, RN and TL. We have to find the length of these 3 sides. Now as PN and PL, if we consider this point P, this PN and PL both are the tangents over here. Suppose the length of both these are X, because both are the tangent from the external point P, so their lengths will be equal. So both of these lengths we are saying it is X. Similarly, if we consider this point Q, then corresponding to this Q, we have this QL and QM, both are the tangents, and we suppose that the length of both these, it is Y, and similarly the length of both these lengths RN and RM, it is Z. So the equations we have is X plus Y is equal to 10 centimeter, or we are saying it is X plus Y is equal to 10, X plus Z is equal to 12, and Y plus Z is equal to 8. Now if we calculate the value of Z from this equation, we will get it is 8 minus Y from this last equation. We substitute this value in this equation and we will obtain X plus 8 minus Y is equal to 12. So we get X minus Y is equal to 4. So we have X plus Y is equal to 10 and X minus Y is equal to 4. So on adding these two equations, we will get 2X is equal to 14. So X is equal to 7. Substituting this value of X in this equation, we will get 7 minus Y is equal to 4. So you will get the Y is equal to 3. Similarly, putting this value of Y over here, we will get Z is equal to 5. So we are saying that the length, these lengths we are talking about, this length is 7. This second length we have to calculate, this is equal to 3. And this third length we have to calculate Z, that is equal to 5 centimeter. These are the required values. Now in this next question, it is given that a circle is inscribed in a triangle ABC and the lengths of the sides they are given to be, this side AB, the length of this whole AB, it is 10 centimeters, AQ is 7 centimeter, and this CQ is 5 centimeter. We have to calculate the length of BC. So if we consider this point A, then AR and AQ, both of these are the tangents. It means this length AR will be 7 centimeter, both these will be equal. If this length is 5 centimeter, then the length of this PC will be 5 centimeter. Now this length over here, this AB length, it is 10 centimeter, and this length is 7. So this RB length, this is equal to 3 centimeter. Now corresponding to this point B, this BR and BP both are the tangent. So this length BP will be 3 centimeter. So this total length comes out to be 3 plus 5 is equal to 8 centimeters. This total length we have, it is 8 centimeters. Next is a circle is touching the side BC of a triangle ABC. This is the triangle ABC given to us, and a circle is touching the side of this triangle at the point P, and touching AB and AC produced at the point Q and R. We have to prove that AQ is equal to half the perimeter of the triangle ABC. Now if we look at this point A over here, then we are saying this length AQ and this length AR both will be equal, because these are the tangents at the point Q and R. If we consider the point B, then we are saying that BQ, that is equal to BP, because this BP and BQ, these are also tangents. If we consider this point C, then the CP and CR are also tangents. So we get CP is equal to CR. Now we have to prove that AQ length we are talking about, this total length, this is equal to, we are talking about this length AQ. We have to prove that this is half the perimeter of the triangle. Now the perimeter of the triangle is, if we calculate the perimeter of the triangle ABC, it is AB plus BP plus PC plus CA. Now we have this value BP, we are talking about this value BP, this is equal to the length BQ. So in place of this BP, we can write it as BQ, and what is AB plus BQ, this whole length is equal to AQ. Now we are talking about the length PC and CA. We have this PC length, we are talking about this length PC, this is equal to the length CR, we are talking about this equation, and what is CR plus CA, that is equal to AR. And from the first equation we have AR is equal to AQ. So we get it is AQ plus AQ, that is equal to 2 times AQ. And this is what we have to prove, that AQ is equal to half the perimeter of the triangle ABC. The next question we have is PA and PB are tangents to the circle with the center O. So these are the two tangents from the point P given to us, and the center of the circle is given to be O. We have to show that the quadrilateral AOBP is cyclic quadrilateral. So we know that the angles that are formed at A and B, both these angles, these are of measure 90 degree. It means angle AOAP plus angle OBP, that is equal to 180 degree, and angle BOA plus angle BPA, that is equal to 180 degree. Since both the pair of opposite angles, the sum of both the pair of opposite angles is 180 degree, so we are saying that this quadrilateral OABP or OAPB, this is a cyclic quadrilateral. In this question we are given that PQ and PR are the tangents, this is the point P given, and PQ and PR are the tangents drawn from the point P, and this angle at P, this is given to be 30 degrees. Now a chord is there, this SR chord, this is drawn parallel to PQ. These two lines, these are given to be parallel to each other, and we have to calculate the angle RQS. We have to calculate this angle over here. This angle we have to calculate. So if we look at this quadrilateral over here, we are first saying that we have done the construction, and the construction is that we have joined this point O and R, we have joined the point O and Q, we extended this tangent PR to N, this tangent PQ to M. This construction is mentioned over here, that we have done this construction. Now if we look at this cyclic quadrilateral ORPQ, why this is cyclic quadrilateral? We know from the property that if we draw the tangent from an external point, two tangents we have drawn, then this quadrilateral we obtain. This is a cyclic quadrilateral. This thing we have also proved in our previous slides. Now this angle over here, this will be 180 minus 30 degree, that is equal to 150 degree. This is the angle at O. This angle at O, this is corresponding to the arc, this RQ. This angle at O, this is corresponding to this arc. On the same arc on the circle, we have this angle QSR, and the value of this angle QSR, this angle, the value of this angle will be 150 by 2, that is equal to 75 degrees. Now next thing is that these two lines, this SR line and this QM line, both these lines, these are parallel to each other. So if this angle at S, this is 75 degree, then this angle at Q, MQS angle, we are saying this is also equal to 75 degree. Both these angles, these will be equal to each other. And the next thing we have is that this angle at S, I am showing in the third figure, this will be equal to this angle at Q. We are talking about PQR angle, and the angle RSQ. Both these angles will be equal. Here of both these angles, this will be 75 degree, because these are the angles in the alternate segment. We have this angle over here, this is also 75 degree. Now the angle we have to measure is this angle, so this will be 180 degree minus 75 degree plus 75 degree, and answer on solving this we will get it is equal to 30 degree, and this is the required angle. Now the next we have is, in the given figure, the sides AB, BC and CA of a triangle ABC. These are the three sides of the triangle we are talking about. They touch a circle with center at O, and the radius R is given for this circle. We have to prove that AB plus CQ, talking about this length AB plus CQ, that is equal to AC, this is the length AC, plus BQ, and we have to prove that the area of the triangle ABC is equal to half the perimeter of triangle APC into R. So for this triangle, we are saying if A is the external point, then this A, P and AR, these are equal, P, B and BQ are equal, Q, C and RC, these are equal to each other. Now if we have shown these results over here, these are the three results we are talking about. Now if we add the first and the last equation, what we get is, or we are saying if we start solving this equation, we are considering the LHS. LHS is AB plus CQ. This AB we can write it as AP plus PB plus CQ. Now CQ, we have it is equal to CR. In place of CQ we can write it as CR. In place of AP we can write it as AR, and in place of PB we can write it as BQ. Now look at this value AR plus CR. These two values will together they will become AC. So the answer we are getting it is AC plus BQ, and this is equal to the RHS. The second part we have shown on the next slide. So to prove the second part, we have done the construction over here, and the construction is we have joined the points OA, OB and OC. Now look at the figure over here. When we look at this, AB as the tangent and OP is the radius, we know that the angle over here in between these two, it is 90 degree. Similarly, the angle between OR and AC is 90 degree, and angle between OQ and BC it is 90 degree. Now if we consider the triangle BOA, the area of this triangle will be half, base is AB and height is R. The area of this second triangle AOC, the area of this triangle will be half, base is AC and radius R is the height of this triangle. When we consider the triangle BOC, we have the area is 1 by 2 into BC into R. If we add all these areas, we will get the area of this whole triangle. We take 1 by 2 common, we are left with AB plus AC plus BC into R. This is equal to 1 by 2. This is the value of perimeter of triangle ABC into R, and this is what we have to prove. Next, in this question, the figure is given to us, and it is given that ABC is a right angled triangle with AB, this side we are saying this is the side AB, its length is 6 centimeter, AC is 8 centimeter. A circle with center O has been inscribed in this triangle. This is the circle we are talking about. It is inscribed in this triangle. We have to calculate the value of the radius R. So to calculate the value of the radius, we are talking about from this center O, we have drawn this F, we have drawn this E, and we have drawn this line OD. All these values, these are equal to the radius R that we have to calculate. Now if we look at this larger triangle, the area of this triangle is half base into height. Look at this triangle over here, OAB. For this triangle, the area is AB half base into height. For this triangle, it is radius, it is R. This is perpendicular over here. The area of this second triangle, this COB we are talking about, area of this triangle, it is half base is CB into height. For this triangle, it is again R. And the third triangle we are talking about, it is AOC. The area of this triangle, it is half into base. For this triangle, it is AC, and height for this triangle, it is this R. If we add all these values, we will get half into AB plus BC plus CA into R, and this value should be equal to half into 6 into 8. Half gets cancelled. What is the value of AB? It is 6 centimeter. Value of BC, it is 8 centimeter, and value of CA, it is 8 centimeter, and value of BC we will get as 6 square plus 8 square root, and whole multiplied by R. So the value of R that we will get, it is equal to, on solving this, you will get the value, it is 10. So this total value, this will become 24. So you will get it is 6 into 8 divided by 24, and the answer we will get that is equal to 2 centimeters. So we are saying the radius of this circle will be 2 centimeters. Now the next question we have is, a triangle ABC is drawn to circumscribe a circle of radius 4 centimeter. So this is shown in the figure that this is the triangle, and there is a circle of radius 4 centimeter. and such that the segments BD and DC into which BC divided by the point of contact D are of the length 6 centimeter and 8 centimeter. This length BD, this is given to be 6 centimeter, and the length DC, this is given to be 8 centimeter. Find the length of the sides A, B and AC. Now if the length BD is 6 centimeter, then the length FB will be 6 centimeter, because B is the external point and BF and BD, these are the tangents. C is the external point, CD and CE are the tangents, so this length will be 8 centimeter. Suppose we are saying the length AF, it is X centimeter, then the length AE is also X centimeters. Now if we calculate the areas corresponding to all these triangles, the answer we will get, it is the area of the triangle we are talking about OBC. The area of this triangle will be half base of this triangle, it is 14, height of this triangle, it is 4. Area of this triangle over here, we are talking about the triangle BOA. The area of this triangle will be half. Base for this triangle, it is 6 plus x, and height of this triangle, it is 4. Similarly, for the third case, for this third triangle, the area of this triangle will be half. Base of this triangle, it is x plus 8, and height for this triangle, it is 4. So the total area we will have, it is 1 by 2 common. It is 6 plus x plus 8 plus 14 into 4. So it is 1 by 2 into 28 plus 2x. So the answer we are getting, it is 14 plus x. So we are saying the area of this whole triangle ABC should be 14 plus x. Now to calculate the area of this triangle ABC, we are using the Heron's formula. We are saying the semi-perimeter for this triangle, this larger triangle we are talking about, this side of the triangle, it is 14 units. This side it is 8 plus x, and this side it is 6 plus x. So semi-perimeter over here, the value of semi-perimeter S, that will be 1 by 2 into 6 plus x plus 8 plus x plus 14. So the answer we are getting, it is equal to 14 plus x. And this value is into 4, this value is into 4. This is the area of this triangle. So we have calculated the semi-perimeter, it is 14 plus x. Now we have to calculate the area of the triangle. The formula we have, it is square root of S into S minus AB, S minus BC, S minus AC. And when we calculate these values, we will get the answer is, we have substituted these values in this formula. You can see the calculations over here. And the answer we will get, it is square root of 48x into x plus 40. Now both these areas, these should be equal in value. So what we are getting is that square root of, we have shown the calculation on the next slide, it is 48x into x plus 14. That is the area of this triangle ABC. That is equal to the area of these smaller triangles we are talking about. One we have calculated ABO, second AOC, and third BOC. We have calculated the area of these three triangles, and the sum of these areas, it is 4 into x plus 14. If we square the both sides, we will get it is 48x into x plus 14. That is equal to 16 into x plus 14 square. You can write it is 48x into x plus 14 minus 16 into x plus 14 square is equal to 0. So x plus 14 is common. We are left with is 48x minus 16x minus 16 into 14, that is equal to 0. So one value of x we are getting, it is minus 14, and this is not possible. And the second value we are obtaining from this, it is x is equal to, on solving this is 32x. So the answer we are getting, it is 16 into 14 divided by 32, and that comes out to be 7 centimeters. So we are saying this length AF, this is 7 centimeter, this length AE, it is 7 centimeter. The value of FB that we have, it is 6 centimeter, and the value of EC we have, it is 8 centimeter. So the total length of this side, it comes out to be 13 centimeter, and for this side it comes out to be 15 centimeters. These are the lengths A, B and AC. Now next it is given that a triangle ABC is drawn to circumscribe a circle of radius 3 centimeters. So this is a circle given and a triangle is drawn to circumscribe this circle, and the segments BD, this BD segment and DC segment, we are saying BC is divided in these 2 points, and where D is the point of contact with the circle, and the length of these segments are given to be 6 centimeter and 8 centimeter. We have to find the side of the area of triangle ABC, and it is given that the area of this triangle ABC is 63 centimeter square. So as shown in the figure, we are saying if this value over here, this is 6 centimeter, then this value BF will be 6 centimeter. If this DC is 8 centimeter, then this EC is 8 centimeter, because these are the tangent from point B and C. Now we are talking about, we are considering this point A over here, and we are saying we have tangents AF and AE, and the length of both these, it is X centimeter. Suppose these values, these are X centimeters, because we have to calculate the sides of this triangle. The radius is given to be 3 centimeter. So again we are considering 3 triangles over here. One is this triangle BOC. One, we are talking about this triangle BOC. Second, we are talking about the triangle CAO. We are talking about this triangle over here, CAO. And third, we are considering the triangle ABO. Third, we are talking about this triangle over here, ABO. We calculate the area of these 3 triangles separately. So the area of this triangle we have, it is half, base is x plus 8 and height is 3, because this will be perpendicular over here. The area of the second triangle will be half, base is 14 and height is 3, because this is perpendicular over here. This is the radius, this is the tangent. And the area of this third triangle we have, it is half, base is 6 plus x and height is 3 centimeter. So the total area we have, it is 1 by 2 into x plus 8 plus 14 plus 6 plus x into 3. So the value we get, it is 1 by 2 into x, 2x plus 28 into 3, and this value is given to be equal to the area of the triangle ABC, that is equal to 63 centimeters. So on solving this 2 gets cancelled, and the answer we are getting, it is 21 is equal to x plus 14. So the value of x that we get, it is equal to 7. So the sides of this triangle, they are 6 plus 7, that is equal to 13 centimeter, and over here 8 plus 7, that is equal to 15 centimeters. Next is in the given figure, XP, this is XP and XQ are 2 tangents to the circle with the center O. These are the tangent drawn from the point X. ARB is another tangent. This is ARB. We are saying this is the another tangent touching the circle at the point R. This is at any point R. We are saying we have to prove that AX, it means we are talking about this length XA plus AR, this length is AR, that is equal to XB plus BR. We have to prove this result. So when we are talking about all these tangents, what we have is that the length of this xp, that is equal to x q, because x is the external point and two tangents are drawn from this point. Now a is the external point and two tangents are drawn, so it is AP is equal to AR. And third, we are saying B is the external point and two tangents are drawn, so it is BR is equal to BQ. Now we are considering, we have to prove this result, that XA plus AR, we consider this left hand side over here. So we are saying what is XA, this XA length we are talking about, this length is XA plus AR. So XA length, when we are looking at this length XA, that is equal to XP minus AP. We are talking about this length XA, this is its value is this, and then we are talking about the length AR, and the length AR we are saying that is equal to AB minus RB. So this is equal to XP minus AP plus AB minus RB. Now in place of XP we can write it as XQ. Using the first equation, we are saying XP is equal to XQ. When we are talking about AP, that is equal to AR. We are saying this is equal to AR. Now we are talking about the length AB. We are saying it is as it is AB minus length RB we are saying, and RB we have this is equal to this length RB we are saying that is equal to BQ. Now look at these two, it is XQ minus BQ. So what we are left with is, from these two terms we are saying, from these two terms, the term we are obtaining, it is BX. And next, from these two terms we are saying it is AB minus AR, it is AB minus AR, that is RB. These two terms when we are talking about, this is equal to plus RB, and this is what we have to prove, that this is equal to XB plus BR. Now in this next question, we are given that P is an external point and O is the center of the circle. This P is the external point from where we have drawn these two tangents, and the angle at P over here, this is given to be 120 degree, and we have to prove that 2 times PQ, this length we are talking about, this is the length PQ, that is equal to PO. So if we enlarge this figure and we look over here, this angle at P over here, this is given to be 120 degree. We know that if we draw a line from the center to the point P, from where we have drawn these tangents, then this is the angle bisector over here. It means this angle we have, it is 60 degree. This angle also we have, it is 60 degree. Both these angles, these are of measure 60 degrees. Now consider this triangle. We are talking about OQP. In this triangle we are saying this is angle of 90 degree, this is 60 degree, so it means this is the hypotenuse. This side over here, this is the base and this is the perpendicular. So if we calculate the value of cos 60 degree, that should be equal to base over, base means PQ over hypotenuse, it is OQ, and the value of cos 60 we know it is equal to 1 by 2. So we get that OQ, that is equal to, we are talking about it is base over hypotenuse, it is not OQ, it is OP we are saying. So what we get is that this OP is equal to 2 times PQ. Q, and this is what we have to do. Next is a quadrilateral ABCD is drawn to circumscribe a circle as shown in the figure. Prove that AB plus CD, we are talking about these two lengths AB plus CD, that is equal to AD plus BC. So suppose we are saying that this length over here, this is x, then this length is x. If this length is y, then this length is y. This length is z, then this length is z. If this length over here, this is w, then this length over here is w. So what we have to prove, if we consider the LHS, it is AB plus CD. What is this length? AB plus CD, it is w plus x plus y plus z. If we consider the RHS part, it is AD plus BC. What is AD? It is w plus z, and BC it is x plus y. And from this equation we can see that LHS is equal to RHS. Why we are getting these conditions? Because if we are saying D is the external point over here, DR and DS, these are the tangent from this point, so both these will be equal. This DR, that is equal to DS. Similarly, we consider this point C, we have two tangent, both of them are equal. Then using these results we can prove this final result, that AB plus CD is equal to AD plus BC. Next is, in the given figure, ABCD is a quadrilateral such that angle D is 90 degree. We are talking about this angle over here, it is of measure 90 degree. A circle with center O and radius R touches the side AB, BC, CD and DA at P, Q, R and S. If BC is equal to the length of this BC, it is given to be 40 centimeter. The length of CD is given to be 25 centimeter, and length of BP, this BP length, this is given to be 28 centimeter. We have to find the radius of the circle. So to find the radius of the circle, we have done the construction over here and we have joined the points O, R and OS. Now if we look at this point B over here, what we get is that from B, BP and BQ, these are the tangents. So this length is also 28 centimeter. If this length is 28 centimeter, then this remaining length CQ will be 12 centimeter. Now if this length is 12 centimeter, then this length CR is also 12 centimeter. So the remaining length DR, that will be 13 centimeter. Now if we look at this figure over here, this angle at R is 90 degree, this angle at S is 90 degree, angle at D is 90 degree, this is given to us. These two angles, these are the radius over here, so that is why these two angles, these are of measure 90 degree. This angle is 90 degree, it is given to us. It means this figure DSOR is a scale. Why it is a scale? Because the angles, they are of measure 90 degree, it is a rectangle. These two sides, these are equal in length, these are of length R. It means this figure DSOR, it has all the angles 90 degree and all the sides, they are of equal length. So that is why we are saying it will be a scale. So what we get is that the value of R will be 13 centimeter, that we have obtained from this. So this is our final answer, that the radius of the circle is 13 centimeters. Next is the theorem we have to prove that a parallelogram circumscribing a circle is a rhombus. So a parallelogram is given, this ABCD is a parallelogram and it is given that it is circumscribing a circle. So we are talking about, if we consider this A as the external point, A, P and AS, these are the tangents. So both these lengths, these are x. these two lengths, similarly these will be y, these two lengths, these will be z, these two lengths we are saying these will be w. Now if we are saying that this figure is a parallelogram. Now parallelogram means that x plus y is equal to w plus z, that is opposite sides, their length it is equal. So what we get is the length of this side we have, that is x plus w, that is equal to y plus z. These two sides, their length should be same. We are saying their length should be same. Now if we are talking about the side, now if we in place of this we add these two equations, we add both these equations, we will get it is 2x plus y plus w, that is equal to 2z plus y plus w. These two gets cancelled and we will get x is equal to z. Substituting this value in one of these equations, we will get y is equal to w. So what we are saying is, in place of this y we can write it as w. In place of z we are writing it as x and x. Now what is the measure of this side over here? It is x plus w. What is the measure of this side over here? It is x plus w. Measure of this side over here, it is x plus w, and measure of this side is x plus w. It is already given that this figure ABCD is a parallelogram, and we have shown that all these sides, they are of equal measure. So a parallelogram with all sides equal, it is a rhombus, and this is what we have to prove, that ABCD is a rhombus. Now next we have to prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle. So we are saying that ABCD is a quadrilateral that is given and it is circumscribing a circle whose center is at this point O. We have to prove that the angle AOB, this angle we are talking about, this angle AOB plus angle COD plus this angle COD, their sum is 180 degree, and similarly the sum of the angle BOC and AOD, it is 180 degree. So to do this we have joined the points OP, these points we are talking about, we have joined the points OP, OQ, OR and OS. We have joined all these points and we have marked these angles as 1, 2, 3, 4, 5, 6, 7 and 8. Now what we see from this is that if we consider this point A over here, then this AP and AS, these are the two tangents from the point A, and we have joined this point A and O. So what we get is that angle 1 and angle 2, we know that this OA is the angle bisector over here, so we are saying angle 1 will be equal to angle 2. Similarly, if we consider this point B, this OB is the angle bisector, then what we get is that angle 3 will be equal to angle 4. Similarly, angle 6 is equal to angle 5 corresponding to this point C, and corresponding to this point D we have angle 8 is equal to angle 7. We have all these values over here. Now the sum of all these angles will be 180 degree. It means we are saying angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8. This is equal to 360 degree because it is angle over here. Now angle 1 is equal to angle 2. So we are talking about these two angles over here. We are saying angle 1 is equal to angle 2. So in place of angle 1 we can write it is, or in place of angle 2 we are writing it as angle 1. Next we are saying angle 3 and angle 4 are equal. So in place of angle 4, angle 3 we are writing it as angle 4. Similarly, angle 5 and 6 are equal. So in place of 6 we are writing it is angle 5, and angle 7 and angle 8 are equal. In place of angle 7 we are writing it is angle 8. So these two values together, this will form angle 1 plus angle 4 plus angle 5 plus angle 8, that is equal to 360 by 2, that is equal to 180 degree. Now what is angle 1 plus angle 8? Look at these two angles over here. This is angle 1 plus angle 8 we are talking about. This is equal to angle, we are saying angle 1 plus angle 8. This is equal to angle AOD plus, what is angle 4 plus 5? 4 plus 5 we are talking about this, it is angle BOC, and sum of these two angles it is 180 degree. So this is the first part, and the sum of remaining two, that is 6 plus 7 plus 2 plus 3 will be 180. So this is what we have to prove, that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle. This is the result that we have to prove, that sum of angle AOB plus COD is 180 degree, sum of angle AOD plus BOC is 180 degrees. Next is in the given figure PA, this we are talking about, this is PA. This is the tangent from the external point P to the circle with center as O. The center of the circle it is O. If angle POB, we are talking about this angle over here, it is given to be 115 degree. Find angle APO. We have to calculate the value of this angle over here. Now we have AOB, this is a straight line. So this angle over here, this is 180 degree minus 115 degree, that is equal to 65 degree. This OA is the radius, this AP is the tangent. So this angle at A, the measure of this angle is 90 degree. So this angle at P will be 180 minus 90 plus 65. The sum of the angles of the triangle it is 180, and the value comes out to be 25 degree. So we are saying the angle at P, its measure is 25 degrees. Next is from a point P, two tangents PA, this is one tangent PA, and second is PB. These are the two tangents are drawn to a circle COR. If OP, we are talking about this is OP, we have joined the center of the circle and P, and the value of this length it is given to be 2R. So what is given to us? This length OA it is R, this length OP it is 2 times R. We have to prove that the triangle APB, APB is this triangle APB. We have to prove that this triangle is an equilateral triangle. Now first thing we have is P is the external point over here. So this length AP and PB, both these lengths, these are equal to each other. Now radius of this circle is given to be R. It means this length OQ is equal to R. This total length is 2R. So this length is also equal to R. So what we get is that Q is the midpoint of the triangle of this side OP. And if we look at this triangle over here, we are talking about the triangle OAP. This is right angled at A. This angle over here, this is 90 degree. Q is the midpoint of this OP. We have joined these 2 points A and Q. We are saying Q is the midpoint of OP. So we are saying Q is equidistant from OA and P. So what we get is that this length OQ is R, this length QP is R, and this length AQ, that is equal to R. We are saying this length AQ is also equal to R. So all the 3 sides of this triangle OQA we are talking about, all the 3 sides of this triangle, its length is R. So it is an equilateral triangle. So what we get is that the angle AOP, this angle over here, this is of measure 60 degree. Angle APO, this angle is of measure, we are talking about this angle at A, this is of measure 90 degree, this angle is of measure 60 degree. So angle at P is of measure 30 degree. We are talking about this angle. This is of measure 30 degree, and we know that this OP, this line we are talking about OP, this is the bisector of angle at P. It means this remaining angle over here at P, its measure is also 30 degree. So the total angle over here, this will be of measure 60 degree. We are saying the total measure of this angle, it is 60 degree. Now look at this triangle over here. We are talking about the triangle ABP. We are saying this angle is 60 degree. Length of this side and length of this side, these both sides, their length is equal. It means these two angles over here, if this is x, then this angle is also of measure x degrees. So what we get is that x plus 60 is equal to 180 degree. So the value of x we will get, it is equal to 60 degree. It means when we are looking at this triangle ABP, all the three angles, they are of measure 60 degree, and this gives us that the triangle PAB is an equilateral triangle. Next is in the given figure XY, this is the side line XY we are talking about, and X dash Y dash, these are parallel tangents. These are the tangents at the point P and Q, and these are the parallel tangents to the circle whose center is O. Another tangent AB, we are saying this is the tangent AB we are talking about, whose point of contact is C, intersects XY at A and X dash Y dash at B. We have to prove that the angle AOB, this angle over here, it is of measure 90 degrees. Now what we have is this angle over here at P, this is of measure 90 degree. This angle at Q, this is of measure 90 degree, because these are the radius and these are the tangent. AB is the tangent, OC is the radius, so this angle is also of measure 90 degree. These three angles we are talking about, all these three angles, these are of measure 90 degree. Now if we look at this quadrilateral over here, we are talking about the quadrilateral APQB. We are saying the sum of this angle is 90 degree, this angle is 90 degree. So what we get from this is that the sum of these two angles, that this angle at A and this angle at B, sum of these two angles will be 180 degrees. Now next thing we have is this angle at A, these two angles we are talking about, these are equal because AO is the line joining the center with A, and AP and AC, these are the two tangents. Similarly for this, we are saying these two angles over here at B, these two angles are of equal measure. It means, suppose the value of this angle is x, value of this angle is x, value of this angle is y, value of this angle is y. So what we have is that 2x plus 2y, that is equal to 180 degree. We have seen over here that the sum of the angles at A and B, it is 180. So we get that x plus y is equal to 90 degree. We are talking about the sum of these two angles. This angle we are saying it is x, and this angle we are saying it is y. Now if we consider the triangle ABO, the sum of all these three angles, it should be 90 degrees. Suppose this angle that we want to measure, its value is z. So we are saying x plus y plus z is equal to 180 degree. Value of x plus y we have, it is 90 degree. So the value of z we get, it is equal to 90 degrees, and this is what we have to prove, that angle AOB is equal to 90 degrees. Next is the incircle of an isosceles triangle ABC with AB is equal to AC. It touches the sides AB, BC and CA at D, E and F respectively. We have to prove that E bisects, this E bisects BC. So A is the external point over here. We are saying if this length is x, then this AD length is x over here. Now it is given that this length AB and AC, both these lengths, these are equal. Suppose the length over here, this is y, this is y. It means this side we have, this is length of this side, it is y minus x. The length of this side, it is y minus x. Now if we consider this point B, then we have BE is the tangent and BD is the tangent. Length of this BD and BE should be same. It means the length of this BE is y minus x. The length of this EC, similarly we are saying, if we consider C as the external point, CF, CE are the tangents, we are saying the length of this length EC, that will be equal to y minus x. It means both these lengths BE and EC, these are equal. It means E bisects BC, and this is what we have to prove.